The Large Hadron Collider is one of the wonders of the modern world.
2, 1, remote stable.
Just when we thought we had the universe figured out, CERN has made a discovery that changes everything.
The collider smashes subatomic particles together with enormous energy. By studying the collisions, scientists have already made a major discovery.
During high-energy collisions at the Large Hadron Collider, scientists observed an anomaly that does not fit into the standard model of physics, which is a framework we have relied on for decades. So what could this discovery be? Could it be a new particle, a hidden force, or perhaps extra dimensions? Let's find out. CERN and LHC. Before we get to the big reveal of what CERN has discovered, let's break down what we are actually looking at. This is the kind of stuff that makes the discovery even more shocking. First, you need to know who is behind all this and what kind of technology we are dealing with. So let's start with CERN. CERN, or the European Organization for Nuclear Research, is where some of the brightest minds in science come together to crack the secrets of the universe. Yeah, it sounds pretty epic, and it is. CERN was founded way back in 1954, and since then, it has been at the forefront of research in particle physics. This is the field of science that studies the tiniest parts of matter. Their work focuses on studying subatomic particles, which are the building blocks of everything in the universe. CERN's mission is to figure out how the universe really works. They want to understand what makes up everything around us, from the air we breathe to the stars in the sky. Over the years, CERN has made some huge discoveries. You might have heard of the Higgs boson, sometimes called the God particle. This particle was discovered in 2012 and helped confirm a major theory in physics called the Standard Model. It was a massive moment for science, and who made it happen? Yes, CERN. But CERN does not just do this by sitting in a lab with computers. They have a tool that makes all this research possible, the Large Hadron Collider, or LHC. LHC is the machine that makes everything at CERN possible. The Large Hadron Collider is the world's largest particle accelerator. Think of it like this. It is a 27-kilometer-long ring buried deep underground on the border of Switzerland and France, where scientists smash particles together at super high speeds. The LHC was turned on in 2008, and it has been running experiments ever since. But what does it actually do? The LHC takes tiny particles, like protons, and accelerates them to nearly the speed of light. Once these particles are flying around the ring, it crashes them into each other. This collision releases an insane amount of energy, which allows scientists to see what happens at a subatomic level. By studying these collisions, they try to see what the universe looked like moments after the Big Bang. The LHC is a powerhouse for discovery. It is the machine that led to the discovery of the Higgs boson, and it is constantly being used to run experiments that help scientists push the boundaries of what we know. Now that you know who CERN is and what the LHC does, it is time to ask the million-dollar question: what did they just discover? The recent discovery. At the core of this new breakthrough from CERN is something scientists never expected: an anomaly. This anomaly was spotted during one of the high-energy experiments at the Large Hadron Collider. Scientists were doing what they usually do, hunting for answers about the universe, when suddenly something totally unexpected showed up. Now, the LHC is no stranger to discoveries. It has been a go-to tool for scientists trying to uncover the mysteries of the universe, from dark matter to dark energy, and even trying to unite the fundamental forces of nature. But this time, what CERN's researchers found was not on anyone's radar. They stumbled upon something while they were analyzing data from protons colliding at insane energy levels. And what did they see? Something that didn't fit the standard model of particle physics. Let's pause for a second. The standard model is a big deal. It has been incredibly reliable in predicting how the building blocks of the universe interact. But this new data, this anomaly, was different. It suggested something outside the rules we have been following for years. It is almost like the universe, for just a moment, lifted the curtain and revealed a new, hidden layer of reality that no one had seen before. The theories. When something this big happens, scientists don't just jump to conclusions. They knew right away that they needed to be super careful before making any bold claims. Extraordinary discoveries need extraordinary proof, right? So they ran simulations, they checked and rechecked the data, and they tried to see if they made any mistakes. After all, the stakes were high. But the shocking thing is that after months of digging into the data from every possible angle, the anomaly persisted. It was not a glitch in the system, and it was not a false alarm. Something completely new had emerged from the chaos of colliding particles. Something no one had predicted. The impossible was happening, and the scientists at CERN knew they were onto something huge. So, what does this all mean? First, this discovery suggests that the standard model, while successful, is not the whole story. It is like when Einstein's theory of relativity changed the way we understood classical physics. This new finding hints that we might need a new framework to explain things that the standard model just cannot. Think about that for a second. One of the most trusted theories in modern science might need an upgrade. But this anomaly does not just rewrite one chapter of physics. It opens up an entire book of questions. Is this a clue to the nature of dark matter? Or could it point to quantum gravity, or even the concept of the multiverse? These are the mind-blowing possibilities that could change how we think about everything. One of the wildest theories floating around is that this anomaly might actually be evidence of dimensions beyond the usual 3 of space and 1 of time. What if there are more dimensions out there that we have not been able to detect yet? If this is true, it could change how we understand not just space and time, but reality itself. The cosmos could be way more complex than we ever imagined. The potential of this discovery does not stop there. One of the most exciting aspects is how it could finally bridge the gap between quantum mechanics and general relativity. These two pillars of modern physics have always existed in their own corners. Quantum mechanics explains the tiniest particles and their behaviors, while general relativity handles the bigger things, like stars, planets, and the structure of space-time. But the problem is that the theories don't get along. For decades, physicists have been trying to figure out how to connect these two theories, and this anomaly at CERN might be the missing link. If that happens, we can expect a major step toward understanding the universe on a much deeper level. Now, we are not saying this new discovery solves everything, but it does bring us closer to something that physicists have been after for ages: a grand unified theory. This is the dream, a theory that would unite the 3 fundamental forces of the standard model: electromagnetism, the weak nuclear force, and the strong nuclear force into a single framework. We are not quite there yet, but this anomaly hints that there might be new forces or particles at play, ones that could unlock some of the biggest mysteries of the universe. And of course, with any groundbreaking discovery like this, we end up with even more questions. What exactly is this new phenomenon? Is it a new particle, a new force, or is it something else entirely that we have not even thought of yet? How does it fit into our bigger picture of the universe? And then, are there practical uses for this discovery? We don't have all the answers yet, but one thing is for sure: this discovery has shaken up the world of physics. While most people are praising CERN for this new discovery, many are criticizing it for putting the human race in danger. What are they so concerned about? How does CERN have the potential to destroy the world? Controversies. One of the biggest controversies is the fear that CERN's experiments could accidentally create a black hole right here on Earth. That's right, a black hole, which is an insanely powerful cosmic object that can swallow everything in its path, even light. Now, why would anyone think that? Well, it is due to the super high energy collisions happening at the LHC. When particles are smashed together at speeds close to the speed of light, the energy released is massive, leading some to worry that a mini black hole could form. But let's clear this up. The black holes people are worried about would not be like the ones in space, which are created when giant stars collapse. If a black hole were to form at CERN, it would be tiny and incredibly short-lived. Scientists say it would disappear in a fraction of a second, long before it could swallow anything. Still, it is enough to make some people nervous. But it is not the only concern right now. Another concern is the possibility that CERN's experiments could open up parallel universes. Some physicists believe there might be multiple universes existing alongside our own, different realities, different laws of physics. And the fear is that by smashing particles together at such high speeds, CERN could potentially crack open a doorway to one of these alternate universes. Now, why would that be a problem? Well, the big worry is that messing with parallel universes could have unintended consequences for our own. What if, by opening that door, something from another universe crosses over into ours? Or worse, what if we disrupt the balance between these universes? The thought is enough to start a lot of late-night conspiracy theories. And while scientists say the chances of this happening are so small, the fear of the unknown keeps people talking. Then there is the controversy over money. Let's face it, building and running the LHC is not cheap. It is one of the most expensive scientific projects ever, costing billions of dollars to construct and maintain. Naturally, some critics question whether it is worth it. They argue that all this money could be better spent elsewhere, on things like healthcare, education, or addressing climate change. People are asking, why are we spending so much on something that seems so theoretical? While CERN's work is undoubtedly groundbreaking, it is easy to understand why some people might think that studying tiny particles and fundamental forces is not exactly urgent compared to, say, tackling poverty or global warming. And for those who don't see the immediate practical benefits, it can feel like a huge waste of resources. But on the other hand, supporters argue that the knowledge gained from CERN's research could eventually lead to life-changing technologies. After all, a lot of the technology we take for granted today, like the internet, came from scientific research that seemed abstract at the time. The question is whether the potential for future breakthroughs is worth the massive investment now. But this is just a small concern. If you hear what other conspiracy theorists have to say, you will probably start a petition to close CERN forever. You see, some people believe that CERN is messing with time itself. The theory goes that the high-energy experiments at the LHC could disrupt the flow of time, causing ripple effects across history. There are even wild claims that CERN's experiments have already caused time shifts, leading to strange phenomena that people have noticed, like objects seemingly changing or memories that don't match up with reality. While most scientists dismiss this as far-fetched, the idea that we could be messing with something as fundamental as time is enough to get some people seriously worried. Time is a fragile concept after all, and it is not totally clear how it might behave under extreme conditions. So even though this might sound outlandish, the fear of messing with time adds to the growing concerns about what CERN's work could unintentionally trigger. Finally, let's get into the most philosophical of the controversies. There are people out there who believe that CERN scientists are tampering with the fundamental aspects of nature in ways that could have unforeseen, possibly catastrophic consequences. These critics argue that by probing the deepest parts of the universe and experimenting with forces we barely understand, scientists are playing a dangerous game. Some go so far as to say that scientists at CERN are playing God by messing with the basic laws that govern existence. They are concerned that this kind of experimentation could lead to outcomes that we are not prepared to handle. After all, we are dealing with forces that were present at the very birth of the universe, forces that shaped everything we know. If we get it wrong, what could happen? Are we prepared for the consequences of poking at the building blocks of reality? The fear is that by messing with such primal forces, CERN might accidentally cause something irreversible. Maybe it is a black hole. Maybe it is opening a gateway to another universe. Or maybe it is something we have not even thought of yet. And that's where the anxiety comes in. Because when you are dealing with the unknown, the worst-case scenarios start to look a little more possible. While the scientists at CERN assure us that they are taking every precaution, the fact remains that we don't fully understand everything about the universe. So there is always a risk, no matter how small, that things could go sideways. These are just some of the major controversies around CERN and its work with the LHC. Whether you are a fan of science or a skeptic, it is hard to deny that what they are doing at CERN is pushing the boundaries of what we know, and with that comes both excitement and fear. Given the success of LHC and the many discoveries it has made, scientists are now trying to create even better versions of it. So what new machines can we expect in the future? In the future, if you thought the Large Hadron Collider was huge, get ready for something even bigger. CERN is working on a new machine called the Future Circular Collider, and it is going to blow the LHC out of the water. While the LHC is already an impressive 27 kilometers in circumference, the FCC is going to be a massive 100 kilometers around. That's more than 3 times bigger, and the power is going to be much stronger, reaching energy levels of 100 teraelectron volts compared to the LHC's 14 TeV. So why build something so massive? The main goal of the FCC is to help scientists get a closer look at the Higgs boson, which is the particle that was discovered back in 2012 thanks to the LHC. But this time, scientists want to study it more. By using the FCC, they will be able to produce more Higgs bosons and study them in much greater detail. This could give us more information about how particles get their mass and how the Higgs field works. But that's not all. With the FCC's extra power, who knows what else might be discovered? Scientists are hoping that this collider could help solve big mysteries like dark matter and new forces that we have never seen before. But CERN is not stopping with just the FCC. They are also working on the International Linear Collider. Unlike the FCC, which is circular, the ILC will be a straight-line accelerator. Why does this matter? Well, a straight-line accelerator means less energy is lost, which could give scientists clearer, more accurate data when particles collide. That means they could get a better picture of what's happening in those tiny, high-energy crashes. There is also another project on the horizon, the Compact Linear Collider. This collider will also be linear, like the ILC, but it is aiming for even higher energy levels. Both of these machines are part of the plan to push the boundaries of what we know about particle physics. Now, why is everyone so excited about these new colliders? It is simple. The more powerful these machines get, the more likely we are to discover something truly groundbreaking. The LHC has already given us incredible insights, but these new colliders could help us answer some of the universe's biggest unanswered questions. Of course, not everyone is entirely comfortable with these experiments. There are always concerns about the unknown, with some people worried about the possibility of creating things like black holes or even opening portals to other dimensions. And while these ideas may sound far-fetched, the fact remains that we are pushing the limits of what we know, and that comes with its own risks. As these powerful new machines are built and switched on, the world will be watching closely to see what they uncover and what new mysteries might arise. So, what do you think? Should we really move forward with this technology, or is it not worth the risk? Tell us in the comments below. If you want to hear more shocking stories, go ahead and subscribe to the channel, because we have got a lot more of this. Thanks for watching. Goodbye.